This tutorial will show you how to carry out Cryo-EM structure determination with AlphaFold models in Phenix using PredictAndBuild. Here are the steps in solving a Cryo-EM structure with PredictAndBuild. First, the structure of each chain in your molecule is predicted with AlphaFold. Then, low-confidence residues are removed and compact domains are identified with process-predicted model. A density-modified optimized map is obtained from your two half maps with Resolve Cryo-EM. The domains are docked and rebuilt with Dock and Rebuild. To try and get a more complete model, the full-length predicted chains are superposed and morphed to match the rebuilt model and are refined. The model with the best map correlation is chosen. The entire procedure is then iterated using the best model from one cycle as a template in AlphaFold prediction in the next. If you want to run PredictAndBuild with Cryo-EM data, you will need the sequences of all the unique chains in your molecule and how many of each are present. These can be supplied as a FASTA file, and two half maps or one full map. If you supply half maps, map optimization by density modification will be carried out. Optionally, you can also supply predicted models, for example if you have run AlphaFold or another prediction method yourself. If your structure contains RNA or DNA, you will need to supply models with approximately the right structure and exactly the right sequences, as AlphaFold does not predict nucleic acid structures. When PredictAndBuild is completed, it will provide a rebuilt model based on AlphaFold predictions and your experimental data that represents your Cryo-EM structure. This is ready for further rebuilding and refinement. PredictAndBuild will also provide a set of one or more full-length predicted models superimposed on your rebuilt model. These are useful as reference models for refinement because they often have very good geometry. Finally, PredictAndBuild will provide a density-modified map suitable for model evaluation and improvement. Let's run PredictAndBuild on a part of a Cryo-EM structure showing an FAB domain of an antibody from PDB entry 7MJS at a resolution of 3 angstroms. In the Phenix main GUI window, select New Project, then select Set Up Tutorial Data, and select the second tutorial, FAB Heavy Chain. Hit OK and your new FAB Heavy Chain project, named AF7MJS for AlphaFold with PDB entry 7MJS, will show up on the left side of your Phenix GUI. If you don't see it, click the Last Modified button to show recent projects. Click on the AlphaFold button and then on the PredictAndBuild Cryo-EM button to open a new PredictAndBuild window. Click Add File and a window showing a directory with the data available for the AF7MJS tutorial will open. Note that this directory contains a README file that describes the tutorial. Select the two half maps and the sequence file, then click Open. This will load the sequence and data into the PredictAndBuild window. Notice that a title has been automatically added. You can edit this if you like. Scroll down a little and you will see that the resolution has been estimated from the two half maps. You can set it yourself if you want. Also, the one unique sequence has been copied from your sequence file and one copy of this sequence was found. You can edit this sequence or the number of copies if you need to. Back up at the top of the page, click on Prediction and Building Settings to show the most commonly used parameters for this tool. In this tutorial, we are going to leave all of the parameters just as they are. Let's have a look at the other parameters on this page, even though we are not going to change them. The number of models is the number of separate predictions that AlphaFold will carry out. The one with the highest PLDDT value is kept. Normally 5 models is plenty. If a very high confidence model is found, no more models will be created. Normally, you will want to include templates from the PDB. Prediction on the first cycle will then be carried out with and without templates, and the highest PLDDT model will be kept. Generally, you will want to include multiple sequence alignments. These provide much of the information for prediction on the first cycle. You can choose to skip multiple sequence alignments after the first cycle. This is useful in cases where the multiple sequence alignment information dominates the prediction even when rebuilt models are being used as templates. You can choose how many iterations of prediction and model building to carry out. This is usually set automatically based on your choice of rebuilding strategy. You will want to use at least 4 processors if you have them available. This will speed up rebuilding. The Phenix AlphaFold server will save sequences used in prediction, the parameters for prediction, and the resulting model if you allow pre-calculated results. If you run again with the same sequence and parameters, the server will just supply the result from the previous run. PredictAndBuild saves intermediate results in a carry-on directory. This allows restarting if something happens and the program stops. To continue a previous run, be sure the right carry-on directory is specified and check Continue this previous run box. In this tutorial, the carry-on directory is supplied with predicted models. If you check the Continue box in this tutorial, then the run will be a normal run, except that predicted models will be taken from the carry-on directory instead of getting them from the server. For now, we will leave this unchecked and use the server. You can find and set other parameters as well. We are all set. Let's hit Run and let this tutorial go ahead. After we hit Run, a new Predict and Build Cryo-EM tab appears. The first thing Predict and Build does is run AlphaFold to predict the structure. Two predictions are run here, one with just the multiple sequence alignment and one including templates from the PDB. After the prediction is finished, a Results tab appears. It shows that the model was predicted with very high confidence. The PLDDT is about 91. 120 residues were predicted with confidence above 70 and 12 with confidence under 70. These 12 residues will be trimmed off before using the model. We will see later that the low confidence residues are in a loop that is incorrect in the AlphaFold model and that needs to be rebuilt. Now Predict and Build is running Cryo-EM density modification with Resolve Cryo-EM using your two half maps to produce an optimized map for docking and rebuilding. The trimmed predicted model is now docked into the optimized map to create a scaffold. Then the full-length predicted model is superimposed on the docked trimmed model with any necessary adjustments made by morphing the full-length predicted model. The morphed model is then rebuilt based on the optimized density map. The first cycle is now complete. The map model correlation for the morphed model was 0.56, a moderate value, while the correlation for the rebuilt model is much higher, 0.73. The RMS coordinate difference between the trimmed predicted model and the refined rebuilt model is just 0.6 angstroms. Note that this does not include the 12 residues that were predicted with low confidence and removed. Now Predict and Build is carrying out a second cycle of prediction and rebuilding. The prediction is going to be done using the rebuilt model from the first cycle as a template. The prediction is finished. It yielded a model with improved confidence. The PLDDT value is now 93. 131 residues have been predicted with confidence over 70 and only one with confidence under 70. The new predicted model has been superimposed on the model from the first cycle and is being rebuilt. The Predict and Build job has now finished and has produced several overall best files. The PDB file is your final model. The map.ccp4 file is your density modified map file. The superposed predicted untrimmed cycle1.pdb file and the corresponding file from cycle 2 contain your AlphaFold predictions from cycle 1 and cycle 2 superimposed on your final model. You can use these to see how the model was changed by using the experimental data. Let's hit Open in Chimera X and look at the predicted and rebuilt models. Here is the final model, overallbest.pdb, in tan, and the superposed predicted model from the first cycle in pink. The models are similar in most places, but the loop at the upper right is rather different. This is the same loop that had low confidence in prediction and that was trimmed before rebuilding in the first cycle. Here is the predicted model on the second cycle in green. It looks a lot more like the final model, and this is because the rebuilt model from the first cycle was used as a template in prediction. This increased both the confidence and the accuracy of the prediction. Here are the final model in tan, the predicted model from the first cycle in pink, and the predicted model from the second cycle in green. And here is the final model shown with the density map. The map model correlation is 0.74, a good value. When your job is done, a button for Refine and Validate appears. If you hit this button, a Real Space Refine window opens with all the necessary files already selected. This is just one of many things you can do next. Your rebuilt and refined model, superimposed predicted models, and map are ready for further refinement, rebuilding, and adding waters and ligands. Best of luck with your structure determination using Phenix and AlphaFold. If you have questions or feedback, you are welcome to contact us at help@phenixonline.org or tutorials@phenixonline.org. We hope you have enjoyed this tutorial on Cryo-EM structure determination with AlphaFold.